We're going to do a problem that involves circular motion and earlier concepts. So let's look at this pendulum. So if we have a 2 kilogram pendulum bob hanging 20 centimeters off the ground with a 50 centimeter long string, and it's going to be released from rest, we're going to determine the following. The velocity at the bottom, so our pendulum bob starts up here 20 centimeters above its 0 point, and it's going to swing down this way, and it's going to be moving at this point. So it starts from rest and then it's moving, so we know that it's accelerating. We're looking for the velocity at the bottom. We're going to draw a free body diagram of the pendulum at the bottom, and we're going to sum up the forces that are acting on the pendulum bob at the bottom and the tension as well. So let's look at A first, the velocity at the bottom. Well, we know something about the pendulum bob up here. We know what kind of energy it has, and we know what kind of energy it has at the bottom. So at the top, it has potential energy gravitational because it's a certain height above the 0. At the bottom, it isn't a certain height above our 0 point, so it strictly has kinetic. So our energy initial equals energy final would be PEG equals KE. And our equations are mgh equals 1/2 mv squared. We'll notice that the m's actually cancel when we solve for v. Velocity is only dependent on acceleration due to gravity and the height. We plug in our givens, 2 times 9.8. We want to make sure we plug in 0.2 meters, not 20 centimeters. We get a velocity of 1.98 meters per second. Now part B, we're going to draw a free body diagram of the pendulum at the bottom. Well, at the bottom, we'll notice it has only tension pulling straight up and gravity straight down. So if we're going to sum up the forces of the pendulum bob at the bottom, tension is up, so it's positive, force of gravity is down, negative, and it's going to equal MAC, acceleration centripetal, since this is moving in a circular path. And AC is positive because it's always directed towards the center of the circle, and our center point is right up here, where the top of the string is. So there's our equation. Now to find for part D, we're going to start with that equation that we just found. T minus Fg equals MAC. Solve for T, you get MAC plus Fg. Plug in our other equations that we know. mv squared over r plus mg is what our equation becomes. Plug in our givens. 2 kilograms for the mass. Velocity was what we found in part A, 1.98 meters per second. And our radius is 0.5 meters. And gravity is 9.8 meters per second squared. When you plug all that into your calculator, double check that you get 35.3 newtons.